Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. When wireless networks fail, the cause is often not a broken device or interference, it's a configuration mistake. The smallest misstep, like a misspelled SSID or mismatched encryption mode, can prevent users from connecting even when the signal is strong and the access point is online. Wireless relies on a complex interplay of settings between the access point and the client device. When those settings don't align, connectivity fails, and troubleshooting can become a frustrating exercise for both network professionals and exam takers. Understanding how wireless configurations work and how they fail is one of the most essential skills to develop. In this episode, we'll explore the most common wireless configuration problems, focusing on SSID settings, encryption mismatches, VLAN assignment, and client-side behavior. You'll learn how these misconfigurations occur, what symptoms they cause, and how to resolve them quickly. Whether you're supporting users in the field or answering scenario-based questions on the Network Plus exam, recognizing configuration mismatches is key to diagnosing wireless issues with speed and accuracy. We begin with one of the most fundamental wireless settings, the SSID, or Service Set Identifier. This is the broadcast name of a wireless network, and clients must match it exactly to connect. A single character difference, an extra space, a missing letter, or incorrect capitalization prevents association. Hidden SSIDs, while sometimes used for security through obscurity, can create problems for users. Clients may not automatically reconnect, and configuring them manually increases the risk of typos. Broadcasting the SSID typically makes the network more usable and easier to manage, especially in environments with multiple authorized users. Misconfigured SSIDs can lead to several specific problems. A typo or mismatch prevents devices from finding or connecting to the network. In environments where multiple APs broadcast the same SSID, inconsistencies in security settings, or VLAN assignments across APs, can confuse clients and lead to inconsistent behavior. Using duplicate SSIDs in adjacent locations, such as multiple tenants in an office building using guest Wi-Fi, can cause roaming issues as clients attempt to connect to the wrong network. Even the case of the letters matters. OfficeNet is not the same as OfficeNet to a client. SSID isolation, sometimes called client isolation, is another configuration option that can produce unexpected results. When enabled, this feature prevents wireless clients on the same SSID from communicating directly with one another. It's commonly used in guest networks to improve security. However, it can also block legitimate services like wireless printing, file sharing, or casting between devices. A user trying to print from their laptop to a wireless printer on the same SSID may fail, not because of a firewall or missing driver, but because the AP is enforcing client isolation. Encryption settings are another frequent source of wireless connection issues. Modern networks typically use WPA2 or WPA3, with authentication either based on a pre-shared key, PSK, or through an enterprise authentication system using 802.1x and radius. Open networks which use no encryption are increasingly discouraged due to security risks. For a client to connect successfully, its encryption settings must match those of the access point. If an access point is set to WPA3 but the client doesn't support it, no connection will be established. Similarly, mismatches in PSK values or passphrases will silently fail, with the user often receiving a vague, unable to connect message. Mismatched encryption modes often lead to authentication failures. For example, if a client is set to WPA2 but the AP requires WPA3 only, the client may not even see the SSID. Some access points support mixed mode, offering WPA2 and WPA3 simultaneously, but this can reduce the security posture and lead to inconsistent behavior. Legacy compatibility modes, while helpful for older devices, increase the risk of downgrade attacks and may result in unpredictable performance. The best approach is to standardize on the highest level of encryption all clients can support and phase out outdated devices. Authentication failures go beyond encryption mismatches. Entering the wrong password is the most obvious cause, but expired credentials, misconfigured radius servers, or missing client certificates are all culprits. In enterprise networks, clients may need to trust a specific root certificate authority, which must be installed and configured properly. If the radius server is unreachable, overloaded, or misconfigured, clients attempting 802.1x authentication will fail silently. Logs on the authentication server and wireless controller can help identify whether the failure is due to credentials, communication, or policy mismatch. DHCP issues are another source of confusion on wireless networks. After a client successfully associates and authenticates, it still needs a valid IP address to communicate. If the DHCP server is unavailable, or if the scope is exhausted, clients may connect to the network but show connected no internet warnings. Misassigned subnets, such as placing a client in the wrong VLAN, may result in IP addresses that can't reach the intended gateway. Clients may appear connected from a wireless standpoint, but all application layer communication will fail, leading users to believe the wireless is broken when the issue is in IP assignment. Static IP address conflicts also produce misleading symptoms. If a device has been manually assigned an IP address that falls within the DHCP scope, it may conflict with another client. This results in duplicate IP detection, which may disconnect one or both devices. The affected client may still show a connection to the SSID, but pings and traffic will fail or be inconsistent. These problems often occur when static IPs are used without proper documentation or reservation, especially on devices like printers or VoIP phones that persist in the environment for long periods. MAC address filtering is a basic access control method that allows or denies devices based on their physical hardware address. While this adds a layer of security, it introduces several management challenges. When a client's network card is replaced or they switch to a new device, the MAC address changes and must be re-added to the filter list. If overlooked, legitimate users will be blocked with no clear error message. MAC filtering is also not scalable in large environments and can lead to support tickets when devices unexpectedly fail to connect. Unless used in tightly controlled scenarios, MAC filtering is best supplemented with stronger authentication mechanisms. For more cyber and content and books, please check out cybersecurity.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Another frequent cause of wireless connection failures is incorrect VLAN assignment on the access point or wireless controller. In many enterprise environments, each SSID is mapped to a specific VLAN, which determines the IP address range and routing policies for connected clients. If a misconfiguration causes an SSID to be tied to the wrong VLAN, clients may receive IP addresses from the wrong subnet or be unable to reach expected gateway. This leads to routing failures, limited connectivity, or complete communication breakdown. These issues are especially common in environments with dynamic VLAN assignments based on authentication or user roles. Captive portals introduce their own class of configuration problems. A captive portal is designed to redirect users to a login or acceptance page before granting full network access. However, this redirection can fail for several reasons. If DNS resolution fails, the client may never reach the portal. If the client already has a cached web page open, it may not trigger the redirect. Some devices block pop-ups or fail to recognize the captive portal altogether, resulting in a connection that appears active but cannot browse the web. Troubleshooting these issues involves clearing DNS caches, ensuring portal pages are accessible, and checking redirection policies on the access point or controller. Wireless issues can also stem from device-specific bugs or limitations. Some wireless chipsets are known to have compatibility problems with certain encryption modes or AP brands. Others may behave unpredictably when roaming or connecting to hidden SSIDs. Operating system updates can change how a device handles authentication, roaming, or band selection, potentially breaking connections that previously worked. In such cases, updating drivers or firmware often resolves the issue. When supporting a broad range of client devices, it's crucial to test configurations across multiple platforms, including laptops, tablets, and mobile phones. Client power-saving features, while useful for battery life, can sometimes interfere with wireless performance. On some devices, the network adapter reduces power consumption by lowering transmit strength, or even turning off the radio during idle periods. This can cause the device to drop off the network temporarily or fail to respond to AP beacons. In enterprise environments, this behavior is often misinterpreted as a coverage issue when it's really a client-side setting. Disabling aggressive power saving on wireless adapters or configuring quality of service profiles to keep the radio awake can improve reliability. On the Network Plus exam, expect several questions that require you to recognize wireless misconfigurations based on user behavior. You might be told that a user can see the SSID but can't connect, and be asked whether the issue is related to encryption, VLAN, or MAC filtering, or you may need to determine why a wireless printer can't be discovered by other clients, pointing to client isolation. You'll also encounter scenarios where DNS, DHCP, or authentication failures are disguised as simple connectivity problems. Knowing how to match symptoms to settings is essential for success on the exam. Best practices for wireless configurations start with consistency, using uniform SSID names across access points, standardizing on supported encryption types, and aligning authentication settings help prevent client confusion. Always test new wireless setups with a variety of devices. Don't assume a configuration that works on one laptop will work across all smartphones or IoT devices. Keep AP and client firmware updated, as manufacturers often release fixes for bugs or compatibility issues. Documenting your configurations, including VLANs assignments, encryption modes, and DHCP scopes, also makes future troubleshooting much easier. When troubleshooting wireless configuration issues, always return to the basics. Recheck SSID spelling and case sensitivity. Verify that encryption settings match between the client and the AP. Confirm VLAN mappings and review DHCP logs for signs of IP assignment failures. Use a known good test client to isolate whether the problem is specific to a user's device or a systemic configuration fault. If possible, test from a guest or open profile to eliminate authentication variables. Wireless problems often look complicated on the surface but are rooted in simple misconfigurations. To summarize, wireless configuration issues are among the most frequent causes of support tickets and exam questions, from SSID mismatches and encryption mode conflicts to DHCP failures and MAC filtering problems. A single misaligned setting can bring an entire connection down. These are not theoretical errors. They happen every day in both small offices and large enterprise networks. The key to resolving them quickly is a deep understanding of how each setting affects the client-AP relationship and using structured, methodical testing to isolate the fault. Every technician should be comfortable navigating wireless settings from both the access point and client perspectives. Know how to interpret behavior, match it to configuration options, and validate fixes across multiple devices. Whether you're reconfiguring a single AP or managing a controller-based system, mastering these core settings empowers you to build reliable, secure wireless environments and solve connectivity issues before they escalate. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.